Hey, welcome back to Math with Patrick. It's March 31st, and we have the 90th problem from this Daily Epsilon calendar to solve. And we need to show why adding this fraction and this fraction together gives us the number 31. So 2 days ago, in my video on the 29th, I was talking about some strategies of how to deal with fractions and arithmetic. And one good strategy is to find a common denominator when you can. And that's what I'm going to try here. So I'm still going to have this 1 in my numerator, but I'd like to find a common denominator in the denominator. It's a little strange to have fractions and fractions, so I'm trying my best to get rid of that. Looks like 31 is going to be that common denominator, but I need to figure out what this new numerator is going to be. And looks like I started with 31, I guess, over 1. And if I'm multiplying the bottom by 31, I should multiply the top also by 31 to get my new value in my numerator without changing the value of my fraction. Like, for example, if you took, I don't know, like 1/2 and decided to multiply the top and the bottom by the same number, you're still going to get a fraction with the same value. So that's what I'm doing here. I'm just going to multiply 31 by 31 to get my new numerator. And I think that's going to be 961. I see that number here, but let's just double check. 1 times 31 is 31, placeholder 0, and then 3 times 1 is 3, and then 3 times 3 is 9, and so adding that all up, we get 961. Cool, okay, so I was right, but it's always good to double check. And should I do that with the other one? We have a 31 on top, and then if I want to find a common denominator here, I guess it's convenient that this is just a 1. So I could just call it a 961 over 961. Okay, that looks pretty good. Simplifying the fraction on the left, I can add the numerators and keep the denominators here. So I have 1 over 962 over 31. And trying to simplify the denominator of the fraction on the right, let's call that a 962 over 961. And again, all I'm doing is adding up these numerators and keeping the denominators the same. So with this fraction on the left, I know that I could simplify it to just 31 over 962. And I guess I want to prove this to you just in case. Say you have 1 over 1/3. This is asking, as a division problem, this is asking how many 1/3s fit into 1. And if we add up 3 of them, we're going to get exactly 1. So this division problem is equal to 3. If you put any other number here, like maybe an 8, well, 8/8 fit into 1. And essentially what we're doing is if you do 1 divided by a fraction, any fraction, maybe not any fraction, there might be some weird divide by 0 things, but most fractions, if you want, you could just think about it as multiplication and flipping the fraction or finding its reciprocal. So this division problem, 1 over 1/8, is going to be the same thing as 1 times 8 over 1. So anytime you're dividing by a fraction, you can just multiply by its reciprocal. And that's kind of what I'm doing here, where I'm keeping this 1 for my numerator right here. I guess it's kind of invisible. Multiplying by 1 doesn't do much. And then I'm deciding to multiply by the reciprocal or the flip of my denominator. So that strategy is going to be super useful for this other fraction because we have this 31 on top already. So this will be the same as 31 times, and then flipping the denominator, 961 over 962. And apparently this is the number 31. I don't quite see it yet. There it is. Let's do some factoring. There's a common factor of 31 in both of these numbers. I could factor 31 out from the first, and I get 1 over 962. And then I can factor 31 out from the second, and I get 961 over 962. And if you notice, the stuff left over in the parentheses is just 1. It's 962 over 962. So 31 times 1 just gets us 31, and that's today's date, so that's the answer for today's problem. So thanks for coming along. It's great solving this problem with you, and I'll see you tomorrow in April. All right.